This video is on naming aromatic compounds. We have seen aromatic compounds before, but we'll get to the aromatic part in chapter 16. First, we'll just worry about the naming. So for example, this 6-membered ring with the 3 double bonds, where the double bonds are conjugated in a cycle, is called benzene, as you should already know. This here is naphthalene. These are base structures, and once we start adding things to them, we can use them as the root of the name. So for example, this benzene ring with a methyl group can be called methylbenzene. However, as this chemical has been known for longer than the naming system, it also has a classical name, which is toluene. However, something like this would be bromobenzene. Or this one here, ethylbenzene. Now you have a go. What would this compound be called? You're correct. It's chlorobenzene. Of course, if the benzene is a substituent as opposed to the root of the structure, it becomes phenol. So for example, this structure here, we have a 2-phenyl heptane. If there is a methyl in between the benzene ring and the main chain, this substituent is actually benzyl. So for example here, this would be 3-benzyl nonane. The same rules of naming apply for all alkanes or any other compounds that we've already learned naming for. However, for these benzene derivatives, we do get new forms of naming if we have a disubstituted species. So say we have a benzene with 2 things attached to it. Recall, if we had more than one substituent on a cyclohexane, we would have to number the positions on the cyclohexane ring. Well, the same applies for benzene rings. However, as molecules get complex and substituents have numbered positions, it has become standardized to also use names for certain positions around the ring that correspond to specific positions. So let's take toluene, right? The methyl group is on the 1 position. We would say it is ipso. The position adjacent to the methyl position, or the 2 position, is referred to as ortho. The 3 position is meta, and the 4 position is para. So for example, this structure here can be 3-chlorotoluene or meta-chlorotoluene. So what do you think para-methyltoluene looks like? You may pause now. And here is the answer. Incidentally, a benzene ring with 2 methyl groups is called a xylene, and therefore this compound here could also be referred to as paraxylene or p-xylene. Note that the ipso, ortho, meta, and para are relative terms, so they are always referring from one substituent to the other. Once we have benzene rings with more than 2 substituents, we cannot use ortho, meta, and para to describe the names of the compounds, but we can use them as relative terms. So for example, in this structure here, we have an ethyl group, an isopropyl group, and a butyl group. The ethyl is ortho to the isopropyl and para to the butyl, whilst the butyl is meta to the isopropyl. See how that works? But what would be the name of this molecule? Well, we can't use the ortho, meta, and para because they are relative terms, so we need to use numbers instead. Keep the lowest numbers, just like with any other organic molecule you have learned to name prior. So this here would be 4-butyl, 1-ethyl, 2-isopropyl benzene. Or, if you recognize a benzene ring with the isopropyl group as cumene, an old common name, you could call this 2-ethyl, 5-butyl cumene. Now you have a go. Name these structures. You may pause now. And here are the answers. A hydroxy group on benzene makes a phenol. Think of it, you have a phenyl group attached to an alcohol, making it a phenol. Alright, this is a very common name, you need to know it. So for example, what is a meta-bromophenol? Well, you draw your phenol, and there's a bromo on the meta position with respect to the hydroxy group. So this is the structure. What about 3,5-dibromophenol? You may pause now. And yes, this is what it looks like. All right, let's move on. So what if you have this structure here? Looks like a toluene with a hydroxy group. Well, this could be para-hydroxytoluene or para-methylphenol. Or if we're really old-fashioned, we can call it para-cresol, because this is the structure of cresol. Now, if that's para-cresol, what is metacresol like? Draw the structure. You may pause now. And yes, this is what metacresol looks like. What if the methyl group is on the oxygen instead of the benzene ring? Well, turns out that is called anisole, another common name. Well, what about if the methyl group is between the benzene and the oxygen? Well, at that point, it's not a phenyl on the alcohol anymore, so it can't be phenol. This now is benzyl alcohol. Note that the substituent is attached to an alcohol and the substituent is benzyl in one perspective or another. If you wanted to call it phenylmethanol instead, that is also fine. But anyway, back to the phenols. Phenols are important because they are more acidic than regular alcohols. Now, if you think back to the chapter on acids and bases, you will probably remember why. If we deprotonate the phenol, we have a resonance stabilized anion that is much more stable than a non-resonance stabilized anion, i.e. the conjugate base is more stable, making the acid more acidic. Now, if you feel like that's too hard to remember and remembering all these names of the chemicals, just know that we haven't even scratched the surface of organic chemistry, but as long as you stick to systematic naming, yes, you will probably encounter names of chemicals that you don't recognize. Well, so be it. That is what Google is for. But if you have to name it, systematic naming will give you the right answer. Now let's practice. Draw the structures for these names and name these structures. You may pause now. And here are the answers.